Okay, so if we consider the same problem now, but with a smaller difference that instead of working at A, we will work at any location in between. So for example, here you have the equation y is equal to 1 over 60 x squared minus 15. If I tell you, for example, if x equal to 4, for example, so for x equal to 4, what will be the normal and the acceleration? Okay, what should we do? So we will do the analysis at any point. Okay, let us call this point B. In this case, at point B, if I want to represent ut and un, ut is always tangent to the path. So it's perpendicular, if you want, it's along the tangent, and it is collinear with the velocity. So here, this is the tangent. How you can determine the direction of ut, the angle it's doing with the horizontal? Because you know that, okay, it's tangent to the path. But when I want to do projections, I want to define this direction. So I want to find what is the angle it's doing with a certain reference. What will be the angle done between ut and the horizontal? Who can tell me? How can I find it? If I call this angle here, I will call it theta. How to calculate the value of theta at any position x?
من ورا الديريفاتيف تبع الواي.
Sorry, can you repeat?
من ورا الديريفاتيف تبع واي.
Very good. انتوا بتعرفوا in math, if I have a function, the tangent slope is equal to what? So this is the tangent line, okay? So ut is along the tangent line. And what is the slope of this line? The slope of this line is dy by dx. Okay? Which slope is dy over dx. So at any value of x, you can calculate the angle theta as, so if this is angle theta here, then angle theta value can be calculated as theta equals to tan minus 1, so or arctangent of let us put it arctangent of dy over dx at the point of interest, okay, at x b. So here, for example, the first derivative is x over 30, so it's equal to arctangent of x over 30. So if they give you, for example, x of b equals to 4, you just replace x by 4 and you calculate the corresponding value of theta. So now we completely defined vector ut. Vector un is perpendicular to ut, directed towards the center of curvature. So it's up because the concavity is upward of this curve. So this is vector un. And since we know the angle ut is doing with x, and un is perpendicular to ut, so also un is well defined. Okay, un will do with y-axis. Which angle? What will be the angle between un and y? It will be equal to theta. Okay, why? Because look, un is perpendicular to ut, y is perpendicular to x. انتوا بتعرفوا, if I have two lines, if I draw the perpendicular to the first and the perpendicular to the second, I will get the same angle. يعني فيكم تقولوا انه x y perpendicular ل x و un perpendicular ل ut, يعني this angle here will be the same as this one. Other method, بما انه un is doing ut is doing an angle theta with y with x, sorry, then it will do with y an angle of pi over 2 minus theta. يعني between ut and y the angle here is pi over 2 minus theta. ولأنه في 90 degrees between un and ut هيبقى between un and y theta. Okay? So you can demonstrate by several methods that the angle between un and y will be equal to the angle between ut and x. So now I completely know the direction of my unit vectors. So I am ready to represent my forces. The forces acting on my skier will be the weight. The weight is always along the vertical, but the normal is perpendicular to contact. يعني هتبطل هون along the vertical and normal لأنه صارت contact line. What is the contact line here? What is the contact line between the skier and the path?
دكتور ما كثير فهمت الكويستشن.
اوكي نحن بس يكون عندنا contact على طول النورمال reaction perpendicular to contact صح؟ The skier is going down the surface مظبوط؟ So the contact between the surface والskier هيكون along the tangent to the path لأنه هيدا الskier here, this is the skier and this is the path of motion. Okay, the contact line between the two هي tangent to the path. So you can say that the normal is perpendicular to UT. مظبوط؟ لأنه if I want to present a normal, it's perpendicular to contact. والcontact line هي along the tangent. So normal is perpendicular to the tangent, so it's perpendicular to UT. So now I can say that normal will be along UN because it's perpendicular to UT and also UN is perpendicular to UT. So my normal reaction will be along UN. So this is N. Okay. Now, once I have my forces, then I am ready to write the equations. Okay. So now if I want to apply to this general case my equations, I will start by sum of forces along UN. Sum of forces along UN equals MAN. First, I have the normal. The normal is completely along UN, so it has only a projection along UN. So it is N minus, for the weight here will be divided into two components. Because if you go back to the figure, the weight has a component, a negative component along UN, and a positive component along UT. Okay? أصلاً منطقيا انه the skier is moving downward under the effect of its weight. يعني اجباري يكون في component of the weight along UT when I am going down because this is the component that will drive me downward. Okay. Now, since the angle between the weight will UN هو theta here, this is the angle between weight and UN. So the projection of weight on UN is cos minus W cosine theta, while the projection of the weight on UT is plus W sine theta. So I will write here N minus W cosine of theta equals to M V square over radius of curvature. أكيد الرو على طول باخده على point of interest. يعني here if I want to calculate the normal at B, so I should calculate rho at B. All I have to do is to replace the coordinates of B in the equation of rho. So this is my equation number 1. Okay, this equation will give me the value of the normal because here they can give me the velocity or not. إذا ما أعطوني الvelocity هقولكم هلا هنشوف أنا وياكم كيف فينا نجيبها if not given. Okay, so from this relation I can get what is the normal reaction at point B. Now, to get the acceleration at point B, I will write the second relation. The second relation is sum of forces along UT equals to MAT equals to, if I project now the forces along UT, the normal has no projection. and the weight has a projection equal to W sine of theta. So you get that M times AT equals to mg sine theta. And if you simplify by m, you get that AT is g sine theta. So as you can see, the tangential acceleration of the sphere is independent of its mass, just depending on the value of the gravitational g, gravitational constant. إذا كنا عم نحكي ب no change in altitude يعني we can take it as 9.81. If not يعني إذا في هلا هون we will deal with constant g. In case it's not the case لازم يعطونا هن what is the variation of altitude. يعني إذا في altitude is varying a lot ساعتها g at each location will have a different value. بس إذا عم نحكي ب ski application, the variation in altitude is the order of in the order of meters. يعني the variation of g will be neglected. Okay, so we can say that AT can be treated as a constant here. هلا بهيدا البروبلم they gave us the velocity. How they can change the problem بطريقة إنه نحن نجيب الvelocity بلا ما يعطونا إياها. They should give us a boundary condition. يعني if they told us إنه we start for example motion from C, if this is point C, they gave us the coordinate of C, and they say that we start they give us for example VC equal to 0. So we start from rest at C, then we can determine the velocity at any point of the curve using two methods. أول method هي بعد ما تعلمناها سوا هي conservation of mechanical energy, but you know it I think from school. We will see it in detail in next chapter. يعني بتعملوا إنه total kinetic energy plus potential energy is constant. Okay, so since you know the change in elevation, you can calculate the variation of velocity. A second method that is in agreement with what we have seen in the previous chapter together, عنا إنه AT is defined as what? AT is dV by dt. مظبوط. So here, because we don't have anything function of time here, بدل ما نحكي ب relation between A, V and time, هنشتغل ب relation between A, V and position S. Because here, the second relation we have developed in the previous chapter here, إنه AT ds equals to VdV. How can I use this formula here to find the variation of velocity? المشكلة عندي إنه I have ds while in my problem the variable هي y و x. So how can I change my variables? It's very simple. لأنه look, if you replace AT by its value, AT is g sine theta times ds equals to VdV. Okay? إذا بتطلعوا منيح, what is ds sine theta? Let us try to find together what is ds sine theta. I will represent in a small figure ds, dy, and dx. S coordinate, curvilinear coordinate هي downward بما إنه عم بنزل. يعني if I want to represent S is like this. It's a coordinate, curvilinear coordinate along motion. So the ds vector will be like this. هون I am amplifying little bit تشوفوها. So this is ds, this is dy, and this is dx. So I will annotate it ds, dy. In this triangle, guys, شو الانجل بين ds و dx? ds is along what? هي along the curved path. يعني هي at any location along the tangent line. يعني أنا كل مطرح عندي ds along the tangent. Okay, so here this is ds along the tangent, here this is ds, here this is ds. So I can say because ds is along the tangent line and the tangent line is doing with the horizontal in angle theta, يعني in this triangle this angle is theta. And because this angle is theta, so I can replace ds sine theta by what؟ شو فيني احط مطرح دي اس sine theta؟ يلا look in the triangle. I can replace the s sine theta by what? So from the triangle, ds sine theta equals to what? Plus dy أو minus dy. مين بيقول لك؟ It is
Minus
dy
dy.
أو y minus dy.
لانه دي اس ليس ذان زيرو.
Exactly. لأنه بس تزيد بس تنقص الواي الاس بتزيد. يعني نحن بس ننزل s is increasing while y is decreasing. So the variation in s is opposite to the variation in y. So I can replace sine theta ds by minus dy. شو بتصير الايكويشن تبعي؟ بتصير minus g dy equals to v dv. وهلا if you just know a boundary condition, you can integrate the first side with respect to y and the second side with respect to v. يعني مثلا if I am going from point C to B, if I know the condition at C, so I will integrate, I can integrate between yc and yb from this side, and I integrate in the other side between velocity at C, which is given, and velocity at B. ساعتها I can find the velocity at any location I want. Okay, هتطلع result of integration بيطلع لي minus g delta y. So this will give me minus g times delta y between points C and B equals to VB square over 2 minus VC square over 2. So just by giving us the boundary condition, we can find the velocity at any point, and therefore we can calculate the normal acceleration. Okay? Any question on this?
No.
Any question, guys, on this problem? So this is chapter 13 mainly. بعد عنا part of application in يعني we'll continue this chapter next time. We have as we have seen together, we can apply the equations. We have seen how to apply them in Cartesian coordinates, rectangular components. رجعنا اليوم شفنا how to apply Newton law in normal tangential coordinates, and next time hopefully we will apply them in cylindrical coordinates. So as expected, نفس methodology. Okay, so in case I want to work in cylindrical coordinates, then I will write شو كانوا unit vectors if you remember the cylindrical coordinates? UR, U theta, U Z. Okay, so next time you will see that in case the كيف تعرفوا شو تستعملوا which type of system? It will always depend on the problem. يعني sometimes إذا أعطوكم R function of theta أكيد حتشتغلوا in cylindrical coordinates, because if you know the equation of the path in UR, U theta, UZ frame, then you should use projection in cylindrical coordinates. So in this case, you will do sum of R equals MAR, sum of theta equals MA theta, and sum of Z equals MAZ. And of course, you will use the derived relation in the previous chapter. AR اللي هي R dot dot minus R theta dot square will A theta equals to R theta dot dot plus 2R dot theta dot will AZ اللي هي Z dot dot. Okay, so we'll see in detail this together next time concerning application of Newton law and cylindrical coordinates. But always it's the same method. I do the free body diagram, I project my forces on the different directions, and I find my answer. Okay, any question before we close? So see you next time. Bye bye.